All right, kiddos, so this is going to be your Unit 1, Day 8 lesson video, and it's going to be pretty quick. So here's a glimpse of your do now. Pretty straightforward. Obviously, I can help you in class and or in tutoring if need be. Um, so first thing we're going to look at, well, the only thing we're going to look at in this video is dilations, okay? And dilations are a non-rigid transformation. We're going to learn about that, all what that means here in a second. Here's our EQs. What is a transformation? What is a non-rigid transformation? What's a scalar? What are the effects of a scalar such that that scalar's absolute value is greater than 1? What if the scalar is equal to 1? And what if the scalar is in between 0 and 1 in absolute value? Okay, so first things first. So let's address our first EQ. So what is a transformation? So let's say I had a triangle, just a little baby triangle like this. And its vertices, we'll call them A, B, and C, right? Well, we define where this triangle exists in space, and we'll call it A1, B1, C1. We define where this triangle exists in space based on where its vertices are on this two-dimensional Cartesian coordinate plane. Okay, so this first of the three vertices is here at 0 by 2. This next one is here at 1 by 0. This next one is here at, what is that? -1 by 0. Okay, so basically what a transformation is when I do something like this. Let's say I draw that exact same triangle, except I draw it over here. And this time, let's say that my base becomes twice as large, which means my height will become twice as large as well. Okay, so let's call this A2, B2, and C2. Well, two things happened. It's in a different area of space, right? And the other thing that happened was the amount of space it occupies changed. Okay? And that's basically what a transformation is. All right? The transformation is simply when you alter where a figure exists in space, or when you alter how much space that figure occupies. Oops. Okay, so our figure in this case was this little baby triangle. Okay, we decided we were going to make this triangle A1, B1, C1 get bigger, right, and go to a different area in space. So it occupies more space now than it did before. It occupies more space now than it did before. And what else can we say? It also is in a different area than where it began. Okay, so all a transformation is when you alter where a figure exists in space or how much space that figure occupies. All right, that's all a transformation is for all intents and purposes in this class. Okay, so now let's look at a little bit simpler of a shape. Simpler as in simpler to understand numerically. Let's look at a square. So I've got a square whose vertices we're going to call A1, B1, C1, and D1, right? Okay, so what we're going to address right now is what is a dilation? Okay, and before I do that, I'm getting ahead of myself. Let's talk about, there's one more thing about transformations that we ought to know, and that is that there's two different kinds. Okay, those two different kinds are rigid transformations and non-rigid transformations. Okay, there's two different kinds of transformations, rigid and non-rigid. Okay, the non-rigid is what we're going to focus on today. Okay, and I'll go ahead and come out and say it. There's only one kind of non-rigid transformation. There's only one kind of non-rigid transformation, and that is dilations. So non-rigid transformations, the only kind is dilations. All right, so back to my little square. Now that I'm not getting ahead of myself. So let's go ahead and label these vertices really quickly. So A1 is at negative 1 by 1. B1 is at positive 1 by 1. C1 is at 1 by negative 1. And D1 is at negative 1 by negative 1. Okay? Now, what are the side lengths of this guy? What are the side lengths of this guy? Well, this guy on this side between A and D, right? This is 2. And if it's a square, truly, all 4 of its sides will be the same. Now, what if I wanted to make this square larger? What if I wanted to make the square larger? So instead of 2 by 2 by 2 by 2, right? What if I wanted it to be, I don't know, 6 by 6 by 6 by 6? Okay? Let's see what that looks like. So what I would basically do to perform a dilation, right? If I want to dilate this square so that its side lengths are 6 instead of 2, I would need a scalar. Okay? So my scalar to go from 2 to 6 would have to be 3. I would multiply all 3 side lengths, or all 4 side lengths, by 3. When I do that, I have to also multiply my ordered pairs by 3. Okay? So what that's going to do for me, I'm going to have to erase some of this. What that's going to do for me after I apply my scalar, and let's see if I can erase careful enough to miss anything important. After I multiply by my scalar, what that's going to do for me is give me the desired result. Let's go ahead and multiply everything by 3. So vertex A1 is going to become, well, what is 3 times negative 1? Negative 3. And 3 times positive 1 will give me positive 3. So that's going to put me here. Again, I'm multiplying by my scalar of 3, right? So that's going to give me a new vertex. We'll call it A2. And it's going to be negative 3 by 3. I would have to do the same thing over here, right? Multiply 1 and 1 by 3. That's going to give me 3 by 3 for my x and y, for my B2, right? That's going to become 3 by 3 because I multiplied by a scalar of 3. And same over here. We can already tell what our shape is fixing to look like. Okay, so this would be my C2. And my coordinates there are going to be 3 by negative 3. And my coordinates here for D2 are going to be negative 3 by negative 3. And if we go ahead and line it all out and just kind of count, well, did we get the desired effect? Well, yes. 2 times 3 gave us 6, just like we wanted. each one of these side lengths is now 6. So what I've done is I took my red triangle, A, B, or not triangle, my red square, A, B, C, D, and I dilated it. By a scalar, and we'll just call this scalar, we'll use K to represent our scalar, by a scalar of 3, and that gave me a new A, B, C, D, right? The side lengths for my red square were 2. The side lengths for my blue square are 6 because of my scalar. I multiplied by K, my scalar, all right? So that really is as easy as this is, okay? Now, what if I wanted to go back smaller? So what if I wanted to go back smaller? What if I wanted a smaller square? In other words, what if my scalar was less than 1? What if my scalar was less than 1? Okay, so what if I dilated this square? What if I dilated this square by, let's see, what could I dilate by? Let's dilate by 1/3. Okay, so what if K was 1/3 now? Meaning I would multiply all my coordinates and side lengths by 1/3. What's going to happen? Well, I would just divide all my coordinate pairs by 3, right? That would give me -1 here for A. That would give me +1 for A's y coordinate. And we can see what we'll come back to. If I multiply 6 by 1/3, that gets me right back to where I started, which was a 2 by 2 by 2 by 2 square. Okay, so basically to answer our number 4, and 5, okay, what are the effects of a scalar such that 1 is less than the absolute value of K? So in other words, if K is more than 1, okay, so if K is a whole number, that's probably the easiest way to say it. If K is a whole number, okay, then what happens? Figure gets larger. Okay, what happens if K is in between 0 and 1? K's absolute value is in between 0 and 1. Okay, in other words, if we have a fraction like 1/3, what happens here to answer our EQ6? The figure gets smaller. Okay, what are the effects of a scalar K such that K equals 1? Well, let's answer that one right now. What if I dilate by a scalar of 1? Well, what is 2 times 1? Well, it would just be 2 again, right? So I'd end up with the exact same square. Okay, if I dilated this guy, the blue square, if I dilated the blue square by a scalar of 1. Okay, if I multiplied by 1 instead, so 1 times 6. Well, my side lengths would stay exactly the same. What would happen to my coordinates? Well, 1 times -3, that's still -3. 1 times +3, that's still +3. And we see that we're going to just stay the same everywhere else as well, right? So what is my answer to this EQ here? Well, my figure doesn't change. All right, and that's all we've got for this video. Besides that, you're going to have the applied practice to work on. And obviously, you're going to have most of class to get that done. And I'm going to be here with you to get it done. If you have any questions over anything from this video, please shoot me an email or come to tutoring or ask me in class. Well, that's all I got. Goodbye.